As Sean mentioned, I'm the CEO of Biarri EMI, which is Energy Mining and Infrastructure, and I'm here today to talk to you about mathematical mining. So as we go through today, I'll start off with just the obligatory company overview and spend a minute or two on that, and then very quickly get into commercial mathematics. What is it? Why do we need it in a general industry sense? And then getting into why it's relevant to mining and what's the benefit it can bring in a mining context. And then I'll get down to some mining examples that we're currently doing or have just done recently with some of our customers, and then moving on to a bit around the future, tying into the future of mining. So without further ado, getting into the obligatory group and company overview. So Biarri is a group of companies focused around commercial mathematics in multiple different industries. So we do a lot of work in things like supply chain, retail, rail. So rail, we do a lot of planning and scheduling, and then getting into networks where we do fiber optic network design for customers like Google Fiber in the US, AT&T, NBN back here at home. And then where I'm speaking from is Biarri EMI, which is Energy Mining and Infrastructure. So really taking that knowledge, capability, and application from all of those different industries and applying it to the resources and heavy asset industries. And just on that, across the group, we're around 140 people, started in Australia, but with a global presence now in Europe and America. So commercial mathematics and analytics, what is it and why do we do it? Rather than going through this is just the standard, Gartner-esque types of analytics, rather than going through them and telling you all about them, I thought I'd go through and give a few examples of where we've applied this in other industries, and then how it's relevant to the mining industry, which you'll see, and some of the benefits we've seen. So starting off with descriptive analytics, really a quick example on that is IVMS vehicle and driver safety analysis. So looking at using the IVMS data and having safety impacts from that. So one of the key findings from that was we noticed that there was a huge spike in the driving that's happening at the start of the day and at the end of the day, when really that's your critical times around dusk and dawn, where you've got the highest safety risk in field driving on remote roads. One of the other benefits we saw from that, using that same data set, was that the vehicles were actually underutilized. So just with a really short and simple project, we were able to come up with millions of dollars of fleet utilization savings costs. So moving on to diagnostic, a couple of examples here. So failure root cause analysis is a really classic one where you see a failure and you're working out what caused it so that you can prevent that in the future. Resource consumption analytics, this is something we do in lots of different industries and have just started doing in the mining industry as well, around wheel wear and fuel consumption. So obviously hot topics in the mining industry. If you can have percentage savings on those things, it makes a big difference to your overall cost. Getting into predictive analytics, so now really getting to, rather than looking at what's happened and getting insights from that for how to change the future, looking at predicting what happens in the future. Obviously one of the key things there is demand forecasting. Any industry that's a retail-based industry, you always have that element of demand forecasting. What's the demand coming up and how do you predict that from a mathematical point of view rather than a purely gut feel point of view. Short-term failure prediction. So this is an example that's actually quite relevant to mining as well. And I can't share the customer, but some really great examples in mining of crusher prediction. So looking at a gyratory crusher, predicting when you're coming up to a failure due to, for example, rebar getting caught in the crusher, so that you can stop the crusher, remove the rebar, and prevent a larger failure event happening. And then getting into prescriptive analytics. So really here looking at rather than saying what will happen, saying what should you do, and that can take into account a lot of the randomness that you consider in the what will happen side of things as well. So a few examples quickly from different industries. Optimized task scheduling, which I'll talk a bit more about in the mining context coming up. but also relevant in a lot of different ways as well. So we do lots of work with Coles and Origin of task scheduling at facilities and at distribution centres. So also applying that in the mining context to your maintenance centres, to your plants, all that sort of thing. Automated network design. So this is a huge one where we see, examples of 80% reduction in the time taken to create a design. We're currently applying this in the oil and gas sector as well to look at the design of not just the gathering network, but also the water, electrical, civil networks that are required to support that. Again, some obvious analogies there to an underground mining context. And then workforce management is pretty much multi-industry across every industry where you've got a large workforce, being able to better roster and optimize the rosters of people to both improve the outcomes for the people and lower the overall cost. So why is this relevant to mining? I mean, I guess at its core, really what we do with this commercial mathematics and the benefits that you get from it can be broken down into doing more with the same amount, which results in increased revenue, or doing the same amount with less, which results in decreased costs, or in some cases doing more with less, which gives you both of these benefits, and then also doing it better, which often comes up with a benefit of increased safety. So obviously some of the examples I've touched on there, a huge safety component. If we look at task scheduling, it gives you a lot of benefits from safety as well through being able to encode some of those rules into your optimization or into your algorithm so that you know that they're always respected or get alerts when they're not respected. So what are some of the things we're doing in mining at the moment? So up here on the screen is just a screenshot of one of the users of our product Cavern at Telfer. So this is an optimized shift planning and short interval control tool, which really fits into that task scheduling component that I talked about. So very focused on the load and haul side of things and focused on having the ability to increase TKMs and also then increase your utilization and decrease idle time and bring visibility to the mine site and obviously the safety component that I just spoke about. So that's the example I was just talking about. A few other things that we're doing at the moment. So algorithmic pit to port value chain optimization. So really looking at how do you move your product from your mine to the port and what are the timings and sequencing that you do that in across that whole value chain to maximize your outcomes from a range of different metrics. That could be reducing cost. It could also be increasing your cash position or your EBIT position. And again, that's something that is not unique to the mining industry, but is of critical value in the mining industry when you look at what impact percentage changes can have. And then that workforce management and rostering that I spoke about earlier, obviously with the remote situation in mining, it only makes this more important and only makes the costs associated with this higher. So the ability to reduce those costs is worth a huge amount to a mining context. And then just quickly before I finish up, talking to what's the next horizon. So really, as we've all heard about over the past couple of days, we're getting more and more data and we're capturing it from more sources. We're capturing larger amounts of data at higher frequencies. And so what are people doing with that data? The more data we have, the harder it becomes for a person to be able to understand that. So really where I see the future of mathematics in mining going is a further uptake of that so that the machines are helping make the decision for you and a lot more analytics enabled web applications and things like that to help make those decisions rather than a person trying to scroll through even hundreds of megabytes of data is impossible for a person to scroll through in a timely fashion. If you take that up to gigabytes or terabytes of data, it becomes even harder. So really that increased adoption of that mathematical algorithm being able to help make those decisions across a whole range of different areas, whether it is failure prediction, scheduling, rostering, any of those areas. Thank you all for listening.
Got time for some questions. Any questions for Dan?
So Dan, one of the advantages of mathematics is you've got an empirically proven optimal case.
Yep.
Are you able to use the fact that it's coming from mathematical laws to be able to state this is the optimal, and does that give you advantages in being able to sell a particular solution?
Yeah, great question. We can in some cases. What we find though is looking at what's theoretically optimal and what's actually optimal for an optimal outcome for the customer, because often those two things don't align with each other quite perfectly, in that a theoretically optimal solution may have absolutely zero buffer or give in the solution, whereas in the real world you know that something's going to go wrong, you're going to need some form of slack in there. So knowing when you want to chase that theoretically optimal solution and when you want to chase a good solution or a great solution that also has some practicality elements to it is really important.
Quick follow-up, just on that point, do you find that there are certain areas where the mathematical modelling component, like scheduling, is relatively straightforward, whereas the other problems that frankly are just not ready yet because there's not a good model for the system in question?
Could you give an example of one of the things you were talking about there?
Well, I think maybe related to the last one. I mean, most engineering problems you have a good understanding of the performance envelope of,
Yep.
of the equipment, but in other areas there might be a need for more empirical characterization. You just don't know what the failure regimes are.
Yep. Yeah.
That's more exploratory, or I think you use the term descriptive.
Yep. Yeah, definitely. So often, even though I broke it down into those 4 different areas, often an individual project or solution will bring in 3 or all 4 of those different areas into actually creating the solution. So you'll often be going there and understanding the problem first and understanding all of that data around it, helping bring that understanding to light before getting into optimization, for example.
As part of your service, you're able to do that modeling component.
Yes, definitely. Yeah, definitely. So we have a lot of consultants working with us as well that do a lot of that and then help get the web application in play, or even just get the once-off insight that might be needed. For example, if you're looking at a facility location problem, you don't need a tool to run that. You just want the insight.
And when you say then, I guess the future rises, this big data, all this data coming in, for your understanding of mining and the mathematics, what do you think is going to be the biggest change we'll see in mining in the next 5 to 10 years?
I think the way in which we design mines will change hugely. There's so much data available to contribute to mine design that isn't really being used in a huge way in that design phase. I think a lot of the things that we talk about are very operational, but really where the big value comes long term is being able to have those step changes in the design of a mine.
Okay.
What's that, sorry?
That comment, can you give me an example? Like of a design difference there?
So, for example, if I use an example of oil and gas or fiber optic network design, there where we're ultimately designing a network, we're able to see 80% improvements in the time taken to create the design, which enables our users to create a lot more scenarios and evaluate a lot more options of how they could do things differently. So, for example, some of the things John Wellborn was talking about in the keynote yesterday around what impact does it have if you change the size of the tunnels that you have, because you've got a fully automated mine and you don't need people access. How does that change your overall cost? Being able to run those scenarios facilitates that step change in cost.
Okay, thanks Dan.
Thank you.
Obviously a hot topic, thank you.